I guess the other problem you've got, you can get steam into the cylinder, but where does it go once it's in there?
With this particular engine, when the steam comes out of the cylinder, it just passes to atmosphere and complete waste. Later engines use the steam more than once.
So we've now entered a very large room with two extremely impressive engines here. So these are the main sewage pumping engines here on the site. And just firstly, from the cylinder down to where the flywheel is, it's about 11 metres in length, this engine, and the flywheel itself is about 7 foot high. It's very grand, David.
These engines were built in 1894 by Haythorne Davy of Leeds, and they have two cylinders on these.
This is where the whole fact that steam is being used twice really comes in.
Yes, when steam leaves the small high-pressure cylinder, there's a lot of useful energy in it, so it's used a second time in the low-pressure cylinder.
And so because the steam has already expanded maybe by a factor of 2 or 3 in the small cylinder, it's going to be a lot bigger, so it's going to take a lot more space. So you need a bigger cylinder to let it expand again a second time and get some more useful work out of it.
What's the benefit of letting it expand again?
Well, essentially, you've still got steam under quite a lot of pressure coming out of the first cylinder because you can't let it expand all the way to atmospheric pressure. The cylinder would be immense and it'd be very expensive to build the engine. And so you can use a second cylinder to let that expand again and get more of the energy out of it, which means you get more work for the same amount of fuel.
So these two processes of expansion are all still basically working, though, to push the piston, David?
That's right, yes. You have a piston in each cylinder, but they're connected to the same rod, which operates the pumps.
And, well, another way to get even more energy out of the steam, I guess, is to use a condenser, which this engine also uses.
That's right. When the steam leaves the low-pressure cylinder, there's still a lot of useful energy there. So it's passed into a condenser, where the steam is then turned into water to be used for feeding the boiler, but also it creates a vacuum. So it's actually sucking the piston along as well as it being pushed, so we get more efficiency.